Okay, can you see my screen?
Yes.
Okay, perfect. So hello everyone, I'm Mariam. I'm part of the JEDI core team, and today I'm going to talk about testing framework in JEDI. And also I'm going to talk a little bit about the practical session that we have this afternoon after this lecture. Okay, so first I'm gonna start by talking about the agile methodology. So this is the method that we use for development of JEDI. And it's a little bit different from the traditional method of software development that is widely used in science. The idea behind the agile method is that we will break down our goal or our the target that we have into smaller pieces, and then work on the smaller piece, one smaller piece, and then after we are finished, we're gonna continue working on the other parts. So the idea is that if you have a big target, you just cut it into smaller one. Let's say you have a smaller piece of code that you want to work on. You have a goal you want to achieve, and then you, for example, you want to add a new feature to JEDI. So you will start by looking at the requirement and then designing the code and then developing it. The next step is to test and review the code. So this is the part that we're gonna talk about, and I'm gonna talk about in this lecture. So after you test the code, you make sure that it's not breaking anything and your code was reviewed by reviewers. You can merge it into the main repository. And then start working on the next piece or the next target that you have. Because you're working on smaller changes in each iteration of the code, it's pretty easy to receive feedback on your code. And also it's easier for the reviewers to review the code because you're only making smaller changes rather than adding a big new feature to the code, which is really hard to follow and hard to test. So, and it's also much more effective in terms of fixing any issues because again, because you only added a small amount of code to the main repository. If there's an issue or if there's a bug, it's pretty easy to go back and fix it. So that's the main idea. And because we are testing it in each iteration, testing is one of the key components of agile methodology. And we need to run the test a lot with every changes that we make in the code. So if we want to classify tests we can classify them into two main categories. One, unit test that we test each component of the code to make sure, like, for example, are inputs correct? Is the answer that you get from your code close to a known answer, and things like that. And we also have application tests that test the whole system to make sure that adding a new feature is not breaking the whole system and everything is working as expected. So in JEDI, we use CTest, which is CMake test driver program to run our tests. Okay, so how do we run CTest? We are by now probably you're familiar with these commands. We ran them on Monday and also in some of the practical sessions. So when we want to run the tests after we build and compile our bundle, in the bundle directory, we can run the test by typing command ctest. So this will trigger, it will trigger running all the tests that are in the bundle. So if we want to run one test specifically, we can use -r and then pass the name of the test, and then it will just run that test alone. We can add verbosity and kind of print more details in the output by adding -v or -vv option to CTest. And also rerun failed will rerun all the tests that failed. So you've seen this kind of summary in practical session. After you run CTest, at the end, it will give you kind of a summary of how many tests failed, how many passes, and then the kind of a time label, how much time was spent in each task. And also if there are any tests that fail, you can kind of look at the list here. And then these two options, if you turn oops debug and oops trace, these two will also add more verbosity to your test outputs. Okay, so what's going on under the hood and what's kind of, if you want to look at the structure of the JEDI testing framework, where should we look? So we're looking at oops repository here, and then the governance of the JEDI testing framework is to have the test directory mirror the source directory. So that means that when you look into the oops repository under source, you can see oops directory, and then under that there are several other directories that include all the .h or kind of header files that are used in JEDI. And then mirror to that, we have test, and also we can see the similar kind of directory structure under test as well. So for example, if we look at oops interface, we see all these header files that are kind of specified in this directory. And then similar to that, if you look at test interface, we see kind of similar files so that are for testing this specific header file. So this is what I mean by mirroring the source directory. Okay, so these are header files, and how do we actually use them in executables? So this is again showing test interface and all the header files that we have there. And then you can find the executable for these header files or .cc files in different applications that we have. For example, if you want to look at QG toy model that exists within oops repository, you can go to oops qc test and then directory executable. So this includes all these .cc files. And if you look, for example, test error covariance.cc, this relates to error covariance.h. So another example, if you look at FE3 JEDI repository, so under test, here it's under mains, not executables. But usually if you look at different models, it's very similar. So when you go to the test directories, you can either see executables or mains. And similar to QG model, you can see that we have test error covariance.cc, which corresponds to this header file. Okay, now we're gonna see what's going on in each of these header files and .cc files. So in this slide and then the next couple of slides, I'm gonna specify some of the important components that we need to have in our in the test header file. So I took this example from getValue.h, so you can find it in the oops repositories under this kind of path. So at the top of the .h file, we have the include files. So I just put some of them. For example, this refers to interface getValue.h. And then we need to have test.h and also test environment.h in our header files. So something that is one of the classes that is very common in most of the header files is test fixture that is usually used to create object based on the configure file or the YAML file. So for example, here we are looking at getValueFixture class, and then we can see that how we read the YAML file using this class. So for example, you can see here, and then I also put a copy of the getValue YAML that is basically used to kind of define the test and put details of how you want to run your test, basically. So for example, if you look here that you are reading geometry from your YAML files, and then you can see the corresponding geometry here, and then it will read it as a result here. Or if we look at locations, you can find the corresponding locations in the YAML file, and it will read it as logs and so on. So you can kind of go to this file for more details. So another kind of class that you will usually see in .header files is the constructors. So test constructors basically make sure that you are constructing and destructing the objects correctly. So here we are looking at test get values constructor, and then you can see that we are using the get value fixture class that we defined earlier. And then here you simply just create the get value object using geometry or resolution and logs or locations. And then to make sure that the object you're created is created correctly, you can use command expect. So if you have expect get value, it just checks to make sure that your object is there. And then you destruct your object and then check to make sure it's destructed correctly. And then using again the expect command. Okay. Okay, another important component in the header file is this register tests. You need to kind of use that in order to register each of the tests that you have in your header file with ECKit. So again, if you go to any of the examples in OOPS interface, you can basically see this register test and then kind of follow that in order to add your tests, kind of register them correctly. Okay, so here I just put some examples of how to use expect command. So expect basically checks checks to see if what is in the parentheses is true, and then it will pass. If it's not true, then it will fail. So you can use it in different modes. There's also another kind of command that you can use with expect is called is close, that will kind of compare to make sure if two variables are close to each other compared to a tolerance level that you specify. Okay, so we looked at the header files, and now we are looking at the .cc or executable files. So I put two examples here from FE3 JEDI, again, looking at get value. So test get values.cc, and then with the same kind of test get values.cc, but in QG model. So you can see that .cc files are pretty short. So you basically just include your test header file here, and then you run the test using run.execute. And you can see that in both of these, they are pretty short and also very similar to each other. Just in this one, you will use FE3 JEDI components, and then in the QG one, you use QG components. And then run.execute, basically execute method is defined. If you want to look at more details, you can see that it's defined under test.h in the OOPS repository. And then I put this I copied the part of the test.h, specifically the execute method here. So you can refer to that to see more details of how you run the tests. But again, probably you will not need to kind of change anything here, depending on your application. But it's very unlikely that you will need to make any modification to test.h. So you can just refer to that to learn more about how the tests run in JEDI. Okay. Okay, so if you want, again, if you want to go back to structure of testing framework, I put an example here of a test directory in FE3 JEDI. So it's very similar in other JEDI repositories. The structure is very similar there as well. So usually in the test directories, you will find cmake list.txt. So in this file, you kind of specified kind of list or register or specify all the files that are used in your tests. So if there's a reference file, if there are YAML files that you use, you need to specify that or register that with CMake here in the CMake list.txt. So for example, the YAML files, you can kind of, you usually see like a sections that includes all the YAML files. And then if you're adding a new test, you need to add your YAML file here. Also, if you can add your test to the C test using ecbuild add test command. Again, you can refer to examples to see the details of how you add a new test to ecbuild add tests. Okay. So data will just include some data files if you want to compare your tests with a known answer. So you kind of keep the known answers. If there's a netcdia file or something like that, you put it in data and store it there. So mains, as we saw before, includes this executable or .cc files related to your tests. Test input, you need to put your YAML file there, the YAMLs that are used to run the tests. And also test output stores the test outputs from the references. And then in some of the tests, you need to compare your test outputs to known answers. And then kind of you store the known answers or known test outputs in this test output directory. Okay. Okay, so here I listed all the steps that you need to take in order to add a new test to JEDI. So there are 7 main steps, but in most cases, almost all cases, you don't need to, you can skip from the steps 1 to 5 because most of the infrastructure is already in place. So you don't need to do any of these. And usually it's step 6 and 7 that you need to take. And that is creating a new configuration YAML file for your test and also register that with CMake and CTest in the CMake list. And then here I put kind of references to useful examples that you can take a look at if you want to write a new test. So you can kind of take a look at the header files and try to follow that for adding a new test. Okay. When you're writing a new test, make sure that your test is not passing all the times because there's no point. So make sure you test your test. This is what I'm trying to say. Make sure that your test is working properly and it fails in the places that it needs to fail. Okay. So a short kind of explanation on the on practical session that we have after this lecture. So you added a practical bounce check filter to UFO, and now you want to add you are going to add a test for this filter. As I said, you don't need to take steps 1 through 5. You can just start by adding the configuration YAML files into test and then test input. And then after that, you will register your test with CMake list, test CMake lists.txt. So more details, you can find more details in the kind of instruction for the practical session. Okay. So now going back to the testing workflow in JEDI. So I talked about how we review the process and how testing is one of the important components of agile methodology. But how do we do it in JEDI? So we use multiple different tools that are available for kind of putting an automated testing framework in place for JEDI. So we know, you know that we use GitHub for as version control system, and all these tools are kind of integrated within GitHub. So we have this automated testing framework in place that will test the code automatically after the code developer has issued a new pull request. So after the new pull request is in place, these automated tools will start testing the system. So we use Travis CI and AWS Code Build for this purpose. So Travis CI is free for open source repositories, but it has limits, computational limits, that makes it not very suitable for all our applications. So we rely mostly on AWS Code Build. So AWS Code Build is not free, but it's not also too expensive. And it's very flexible in terms of you can pick there are different options in terms of computational power that you can pick based on your needs, and you can pay for that. And then we use containers in order to test the systems in different environments. And then I will talk a little bit more about that in the next slides. So after we run our tests using AWS Code Build or Travis CI, we post the test outputs to the PR page using webhooks. And then, as I mentioned, using different containers, we can run multiple configurations and test the code in multiple environments. And because we are using cloud computing, we can run them in parallel, which makes it a lot faster. And then after all the all the tests pass, we can merge the code, and then the reviewers approve the code. We can merge it into the main repository. If the test fails, they need it. The PR needs to go back to the code developer, and they need to take care of the test failures. So we use Docker containers in our AWS and Travis CI system, and we have 3 different containers based on 3 different compilers, GNU, CLang, and Intel. And then we use those in order to kind of thoroughly test JEDI code in different environments, and that ensures that we are not failing if we change the compiler or the environment. Okay, so here's an example of automated testing interface. So we are looking at OOPS repository. So in the pull request page, you can see kind of red cross, green check, or yellow circle that shows the test outputs for each of these pull requests. For example, here this sign shows that this pull request failed in one of the containers, or this shows that everything passed. And this one kind of shows that the tests are still running and it's a pending status. So here I've just wanted to show that how it's integrated within GitHub. And then in each pull request page, you can kind of see the results of these kind of tests that we ran. So 3 different containers on AWS, and then Travis CI uses a GNU container to run the tests. And also clicking on each of them, it will take you to kind of the test outputs and shows more details about kind of how we built the system and how we ran the test. We also have another tool that is in place. It's called code coverage. So this is kind of to ensure that when we are adding a new feature, we are not reducing the test coverage in our code, meaning that whenever you add a new feature, you need to add a test with that. Otherwise, the test coverage will be reduced, and we don't want that. So this just reminds the developers how much test has been added, how much code has been added, and how much coverage is changed with every change with every PR, basically. So right now we have so almost 90%, I mean, more than 80% for most of our repositories, main repositories, is the test coverage that we have right now. And we are hoping to increase it with new development and never decrease it. So we always want to add more tests to our system. Okay. So this is my last slide, just a friendly reminder that please add tests when you add a new feature to the code. And then make sure you build the system and run the test with the new feature that you're adding before issuing the pull request on GitHub. Basically, do not use Travis CI code or code build to debug the new feature. You need to test it on your own machine before sending it back to GitHub. And also, as it was also mentioned in one of the lectures, I guess, that tests are great examples that you can take a look at to learn how the code, how you can basically use the code. So I highly recommend going into the test directories and take a look at different header files, different executables, and learn how the code is used in the tests. And this is my last slide.